Okay, today we are going to talk about multiplying special cases. Now, a special case is no different than just FOILing. When we see, like example 1, x plus 7 times x plus 7, we know this by using the definition of exponents. The base is x plus 7, and I'm multiplying it times itself twice. So I could write x plus 7 times x plus 7 this way in expanded form, or I could write it as an exponent. So when they give us a couple of the special cases, or one kind of the special cases, is they will give it to you looking like this. They're going to say x plus 7 squared. What you're going to do is you're going to realize that that means x plus 7 times x plus 7. And when you have two binomials that are being multiplied with each other, you have to FOIL them. So we're going to take our first, our outer, our inner, and our last. The first times the first is x squared. The outer, so x times 7 is plus 7x. And then 7 times x is another 7x. And 7 times 7 is positive 49. And when I combine my middle terms, I'm going to get x squared plus 14x plus 49. So these are special cases because they're taking one particular binomial and it's multiplying it times itself. And we're still just going to FOIL them out, and the inner terms are always going to group, and there we have our answer. So this is not that difficult. Why don't you go ahead and try x plus 6 squared. You can pause this and try it. All right, so I like to have you guys write out x plus 6 times x plus 6. And when I FOIL it, my first terms give me an x squared. Then if I distribute this x over here, I get a plus 6x. Then I have 6 times x is another 6x, and 6 times 6 is 36. And when I combine my middle terms, I'm going to get x squared plus 12x plus 36, because these are like terms and they group. All right, try this one. 5y plus 1 squared. You can pause this. All right. So if you have 5y plus 1 times the quantity of 5y plus 1, I'm going to multiply the first terms together, and that's 25y squared, and then the outer terms together is plus 5y, the inner terms together is plus another 5y, and 1 times 1 is 1. So when I group like terms, my inner terms are like terms, I'm going to get 25y squared plus 10y plus 1. Let's make sure you can see that. All right, let's try another one. This one, we have two variables in it, so it's a little trickier, but you just have to FOIL and keep track of all the different variables. So you can pause this. All right, I think it's easiest if you just rewrite the two polynomials, 7m minus 2p and 7m minus 2p, and then I FOIL it. So the first times the first is 49m squared. Then the outers are negative 14mp. The inner is again the same thing, negative 14mp, negative 14mp. And then a negative 2p times a negative 2p is a positive 4p squared. again, my inner terms combine, so I get 49 m squared minus 28 mp plus 4p squared. All right, good. Now, why don't you guys try this one? You can pause this. All right. So again, I would write this out as 9c minus 8d times the quantity of 9c minus 8d. When I multiply my first term times its first term, I'm going to get 81c squared. I'm going to get the negative 72cd, and then I'm going to multiply the inner terms, and I'm going to get another negative 72cd. And then a negative times a negative is a positive 64d squared. All right, and then again, my inner terms group, because they're like terms, they both have a c and a d in it. So I'm going to get 81c squared minus 144cd plus 64d squared. Okay. All right, so that's our first example, and we're taking and squaring two binomials. This is a binomial squared, and so anything that's being squared, the answer to this is a perfect square. If I square this, the answer to this is called a perfect square. Just like if I square 2, the answer is 4. 4 is called a perfect square. And that we'll be interested in that when we start trying to reverse this process. All right, let's look at this next one, example 2. Now, it looks like they're the same. We have the same variable and the same number, only our signs are different. This one has a plus and this one has a minus. These are called conjugates of each other. But we're going to do the same thing, and we're going to FOIL these. So the first term times the first term is d squared. The outer terms, I'm going to get a negative 11d. And the inner terms, I'm not going to get a negative 11d. I'm going to get a positive 11d. And then when I multiply a negative 11 times a positive 11, I get a negative 121. Now, as usual, my inner terms are like terms, and when I combine them, look what happens to them. A negative 11d plus an 11d, they cancel each other out. So I'm left with d squared minus 121. When you multiply conjugates of each other, conjugates are where you have the same variable and the same constant, only they're different. The difference is the signs. One's a plus and one's a minus. The inner terms always cancel, and I'm left with what we call is the difference between two squares. The square of d is d squared, and 121 is 11 squared. So this is a square, and this is a square, and we have the difference between the two. And that just happens to be what we call that. And that's a pattern that we see happening over and over again when we multiply conjugates. All right, so let's try this one. Do you guys, if you want to try it, go ahead and pause. If you would like me to work it, then just keep it going. Hopefully you paused it because you're all energetic and know what you're doing. So we see that we have conjugates of each other. One's a plus and one's a minus. So we're anticipating our middle term will disappear. C squared times c squared is c to the 4th. C squared times negative 8 is negative 8c squared. Positive 8 times c squared is a plus 8c squared. And negative 8 times positive 8 is negative 64. Now, as anticipated, my inner terms cancel with each other. They're like terms, and one's positive, one's negative, and I'm left with c to the 4th minus 64. And these are the difference between two squares. This is c squared times c squared, and this is 8 times 8. All right, now I think you guys can try this one. Be careful with those variables, with the exponents of the variables. And you can pause this. All right, let's multiply this one. So first times first is going to be an 81b to the 6th power. Because it's, remember, when you multiply exponents with the same base, you add the exponents. So 3 plus 3 is 6. And then 9b cubed times negative w to the 4th is just negative 9b to the 3rd w to the 4th. And then I'm going to multiply a positive 9b to the 3rd w to the 4th. And then w to the 4th times a negative w to the 4th is negative w, and 4 plus 4 is 8. The inner terms cancel, and I end up with 81 v to the 6th minus w to the 8th. And that's how you multiply special cases. Good luck.